All right, guys, I think we'll get started. It's almost 7 o'clock, so close enough. Want to appreciate you showing up tonight. I think we've got a pretty good talk. I saw Bill at IBM just a couple weeks ago, and they gave him all of 10 minutes to speak, and it wasn't quite enough. So maybe if we give him more of an hour, he can give us a little more details. So anyway, tonight our speaker is Bill Rapp. He's a IBM Distinguished Engineer and Chief Architect of Watson Cognitive Healthcare Solutions, which is really one of IBM's main focal points going forward. As such, he's leading the technical team that is adapting Watson for use by the healthcare industry. Prior to this, Bill was the co-director of the Medical Imaging Informatics Innovation Center, which was a joint collaboration between IBM and Mayo, and Chief Technology Officer for IBM's Healthcare and Life Science Division. Bill holds over 24 patents, has co-authored numerous publications, has got 38 years of experience in system and software architectures, and 14 of those years he spent in the healthcare related technologies. So with that, we'll welcome Bill Rapp. Got kicked off, huh? If don't.
All right, it's still displaying this.
Yep, so we'll give you that.
Switching this.
I think it's on.
All right, can you hear me? Yes. All right, good evening. Just down a bit. Well, as far as I can go. Well, thank you for inviting me. We're still not displaying here. Working on it. But while he's working on that, as my intro said, I'm the chief architect for Watson for Healthcare. We have a team of developers here in Rochester that work on Watson, dedicated primarily to healthcare. We've been working on that for ever since the Watson won the Jeopardy game. Healthcare was the first industry that we decided to use Watson for. So the team in Rochester here was the first one to work on that. So we've been developing applications ever since, and working with this incredible technology to try to adapt it to the healthcare industry. And I'm going to take you through today a little bit about what we're trying to do with healthcare. And where cognitive computing fits, how we're using cognitive computing in the healthcare industry, and where this technology is going and how I see us using this. There we go. And then I'll take questions as I'm talking, and we can also there'll be time for a question and answer after I get through too. So don't be shy in asking questions. I want to make sure I tailor this to what your interests are. But again, the focus today is on using Watson for the healthcare industry. So let's first talk about what things we're interested in and working on and defining the healthcare industry and the forces that are driving it that in turn are driving cognitive computing. So healthcare actually isn't that much different than a lot of industries. It's in terms of what their pain points are, what their key challenges are. First of all, there's a information deluge. There's the amount of information that's coming out, and I got some charts further on to kind of give you an idea of what that is. Increases, doubles in this case it says the literature doubles every few years, but beyond that, we're talking days. I think the latest information is medical information doubles in like 75 days. It's just amazing how much stuff is coming out. And obviously, that can't be navigated by humans anymore. So we understand not only the need for computers to do that, but specialized computers like cognitive computing to be able to make sense of all that data. Secondly, demand is outstripping supply. The physicians are saying, especially across the world, that there are not enough physicians coming on board to handle the healthcare needs of the population. And we've all seen that, and we know that's coming, but that's certainly driving this one's still working? Yeah. So that's driving the need for the type of computing that we're talking about. And also the patients aren't being offered the treatment options that they're needed, and it's because we can't process the information. So for example, cancer patients aren't being offered clinical trials when in reality that's the best solution for them. And patients don't have enough information available to them to participate. We always want patients to participate in their healthcare coverage, but if they don't have the knowledge and the information they need to do that, then they can't make that participation. So these are some of the things that we're working on in the healthcare industry. But let's get into a little bit some more specifics here. So when we deal with healthcare with Watson, there's really two constituents that we're initially working with and that we have been working with over the years, and I guess a third one would be the patient themselves, which is something that we're starting working on now. But from a professional point of view, the first one we work with is the clinicians and look at their challenges. And basically it comes down to the number one thing that the physicians, the clinicians have to do is understand their patient's condition. So understand very quickly, and they have very little time to meet with their patients, very little time to prep for their patients, but in a very short period of time, they need to be able to understand the patient's condition. So given the variety of places that patient information is stored, electronic medical records, including lab reports, pathology reports, radiology reports, etc. How do we summarize that information, and how do we do it in a way that this specific physician or this category of physician wants to see it? So how do we summarize thousands of pages, specifically, especially for chronically ill patients? It could be literally tens of thousands of pages of information. How do we summarize that for an oncologist or a cardiologist? That's the first challenge that we have to do is help them understand the patient condition in a timely manner. Secondly is then formulating treatment options. So for this particular patients and all their characteristics, what would the guidelines say? What is the standard of care for this patient? And this comes from different guidelines and gets them down to a list of things that are possible for this particular patient. And then third is selecting personalized treatment plans for this particular patient. So if we ask a few more questions, get a little more answer, then we can narrow this down into a handful of treatment options, or perhaps a single treatment option that's right for this patient that takes in the scientific aspects as well as the patient preferences. So that's one aspect of things that we're working on and using Watson and cognitive computing for. The second is the researchers, and in companies like Mayo, a lot of the clinicians, most of the clinicians are also researchers. But researchers have a different type of challenge. Their challenge is just staying up to date with the latest information. So the volume of information that comes out is incredible, and staying up to date with that medical literature is virtually impossible. It has to be waded through and has to be summarized into something that they can understand. What they're looking for in their particular area of specialty is uncovering novel connections between disease and pathways and drugs and things like that. And they need a way to navigate through all that information to be able to find that. And then looking for new insights in future research, looking at published literature, looking at patents and things to see what the rest of the world is working on and how they can build on what they're doing in their particular area of expertise. But fortunately or unfortunately, if you look at the bottom number here, 80% of the world's healthcare data is unstructured, and that's exactly the problem. It's not accessible through traditional computing mechanisms. And so here's an example of that. So basically, unstructured data is messy, and that's really what we're dealing with here, whether it be patient summary reports, patient history, lab reports, radiology reports, what have you. It's very complex data, has complex clinical concepts and relationships that have to be understood. It's written using human language, which by nature is ambiguous. In order to understand it, you have to understand it within the context in which these terms and sentences were used. There is a vocabulary, luckily, since we're dealing with medicine, but that vocabulary and those coding conventions are not used consistently across, so we have to compensate for that. So very, very difficult problem, and the reason we need cognitive computing. To make things worse, as I mentioned earlier, this data is growing at incredible rates. When I started working in healthcare industry about 14 years ago, all we dealt with was this portion of data. Let's see, where's my cursor? This portion of data here, the clinical factors. So everything was lab results and radiology reports and things like that. And although it was quite expansive, if you look at it today, that's really, those clinical factors are only 10% of the data that we have to process today. Adding to that, 10 years ago was putting in genomic factors. So what's the genome of this particular patient, and what's the genome of, if the patient has cancer, what's the genome of the tumors in their cancer, and how does that affect their care, and what are the relationships between genomes and disease and pathways and things like that. But even that represents only 30%. Still a lot of data, 6 terabytes of data for the lifetime of a patient. But now we've got this information that we're calling exogenous factors. So everything we've done up till now has been trying to figure out what's wrong with the patient, trying to help them with treatments and fix the problems they have after they occur. Well, the focus now is how do we prevent people from getting these diseases and getting these illnesses in the first place. And that's where exogenous factors come in. So this is all the information that we're collecting on your smartphones and your smartwatches, embeddable device, wearable devices, anything that deals with your heart rate or your glucose monitors, your lifestyle information. It deals with how are you feeling that you might be talking about on Twitter or Facebook or those types of things. All of that could affect your care. In fact, one of the things that we found out in some of our experiences is one of the factors that can determine your outcome. For example, we did a study on like knee replacements, and there's all kinds of medical factors that can affect what your outcome is on a successful knee replacement or hip replacement or things like that. But one of the key success factors is do you have a goal in mind? So if you're goal oriented and you say, well, why am I getting my knee replaced? If it's just because, you know, it hurts, that might not be enough to drive you to a successful conclusion. But if your goal is, I want to be able to dance at my daughter's wedding, or I want to, you know, do something like that, you're more likely to be successful with that treatment because you're going to work on it, because you have a goal and you're going to do whatever it takes. So those social factors, along with all the exogenous factors, are things we have to start taking into account. And if you look at that data, 1,100 terabytes of data that we have to crawl through, and a lot of that is unstructured, human-oriented, messy, difficult, and not something you can deal with today's traditional computing mechanisms. So enter the opportunity, the cognitive opportunity, and why we picked healthcare as the first industry to adapt Watson. So let's make sure we're all on the same page here in terms of how we define cognitive computing. And we call it cognitive computing, not artificial intelligence, although those two are often used together. You can see we define it here on top as a conscious mental activity. But to be more specific, when IBM and when I think about what we're doing with cognitive computing, it's all different kinds of aspects of that we're focused on. So these 5 things are things that I think define what we're doing with cognitive computing. Number 1 is it's a computing system that learns and builds knowledge from both structured and unstructured. So it's not just taking all that unstructured, but it's combining it with the structured lab reports and things like that, and building knowledge from that. This is actionable knowledge that we can pass on to the end user and help them with making decisions. Secondly, it's something that understands natural language. So that's a key part and a key difficulty that we have with cognitive computing. It's addressing this information, this messy information that couldn't be dealt with any other way. And that's written in human language so that it can interact more readily and more naturally with humans, either on the input side or the output side. Third, it's something that captures the expertise of top performers. So we're trying to learn, and it's a learning system, but we don't necessarily want to just learn from everything that's out there. We want to learn from the best. So we want to learn from how the top performers treat their patients, either through past historical cases, or we'll even get down to the point where we'll interview these physicians, the experts in the industry, and see how they make decisions, why they make certain trade-offs and things and that, and try to build those things into Watson. So we'll use any mechanism that's available of making Watson, making our solutions smarter. Some are very cognitive in nature. Some may not look as cognitive in the sense that we're actually capturing information from interviews with doctors. But being able to capture the expertise of top performers and being able to translate that back to experiences and recommendations for others is key to cognitive computers. Fourth, it enhances the cognitive process of professionals to improve decision making. So what we're doing, and notice we worded that carefully, we're enhancing the cognitive process. So we're not trying to give answers. We're not trying to say, this is what you should do, this is the treatment you use. We're trying to provide the information and the recommendations. We're trying to give treatment options, for instance, for a doctor to help them make better decisions. So our goal is not to replace that decision making, but to augment that decision making. And then fifth is elevate the quality, consistency to decision-making across an entire organization. So one thing about cognitive computers in Watson is it's not biased at all. It doesn't have any emotion, so it's not making emotional decisions. And if everybody uses this and is taking this recommendations, we're working from the same base, we're working from the same level of expertise, and it's making unbiased decisions that can now provide consistency, not only across an organization, but across the industry. So when we set out to make our Watson treatment solution, this is something that we wanted to learn from the experts like Memorial Sloan Kettering, Mayo Clinic, and others, and be able to share that knowledge with cancer centers and clinics across the nation, even the very small ones, so to get some consistency in our decision making. So that's how we define cognitive computing, and I'll go through a little more detail on this and then show you some of the applications that we've built using this methodology. Okay, so a lot of people wonder, what's different between regular analytics or cognitive computing? Isn't this just another form of analytics? And it's really not. In some sense, it's kind of the same thing. We're not saying that we're replacing any existing analytic capabilities. Whatever analysis that we're currently doing with structured data or even some unstructured data, we would encourage and continue that. But we're looking at cognitive computing as something that complements or augments traditional analytics. And if you do a comparison here, traditional analytics where it really addresses predefined problems using very curated types of data. So its emphasis on good data in, good output, good answers out, and spends a lot of time curating that information so you get very accurate answers. In cognitive computing, we're starting with information, as I said, is messy, it's ambiguous. It's not something we can deal with readily. So we're starting with ambiguous problems. So the answers that we give might be somewhat ambiguous also. So whereas traditional analytics provides accurate and definitive answers, in cognitive computing, we're providing answers with a margin of error. Well, based on the information that I have, based on the way it was stated, based on what I know for this patient or for this individual, these are the recommendations I can give. Here's my confidence in what that is, and you can factor that into your thinking. So we can't compare, and this is a mistake a lot of people make, traditional analytics with cognitive computing analytics, because we're starting from a different base. What you should be comparing is, without cognitive computing, what did I do with that 80% of the data that was unusable before? You want to compare that with cognitive computing, where I can take that 80% of data and I can make use out of it. And in some cases, we can get very, very accurate with that. In some cases, we can't do that, and that's where the margin of error comes in. And you can see the other things. Cognitive computing handles information without explicitly knowing semantics. So it's we don't spend a lot of time ahead of time dealing with different type systems and definitions and things like that. All of that is kind of learned by doing, learned through past cases and things like that. So that's really the difference and the reason why cognitive computing is needed. So let's talk about the way forward here and where I think cognitive computing is and where it's headed. So this is my list of I call it the cognitive progression of where we've come from and where we're going here, and the different flavors of cognitive computing. So I don't want people thinking cognitive computing is one thing. So when you first start out, obviously one form of cognitive computing we all use is kind of search, search using Google search or Yahoo or any type of search mechanism. And we can get into more and more complex searches, semantic searches and things like that. So that's kind of people's first introduction into cognitive computing, and every cognitive computer has to be able to do that, is, just show me, let me type in keywords and give me references to documents. The next level is question and answer. So let me actually enter my information in my question, type in my question or speak my question, and instead of giving references to documents, give me the actual answers. So this was the jeopardy, and this is, I think, most people's view of what cognitive computing is that view of jeopardy where I can ask it any question and it gives me the answers. But if that's where we stop, then there's all kinds of things we haven't done, because there's many other ways we can interact with our cognitive computers, and in reality, just using the kind of the question answer is too limiting. It's not an expressive enough way for you to express what you're really looking for. So then we get into kind of the next layer, which is dialoguing, which says, okay, you ask the question, I'll give you the answer as best I know it, but let me ask you more questions. Well, based on what you ask, here's what I think, but is this what you really meant? Did you mean this or this? Or what, what kind of disease are we talking about? Or what, here's some other information that if you provided, I could give you a better answer. So now you start having this computer to human interaction, so we can clarify what your intent and improve our answers. The next level, and by the way, these don't necessarily have to go in order. You can skip around and do different things, is visualizations. So another way we have built into a lot of our solutions now is just the standard text input or voice input and output is not sufficient. But if I can start to visualize this information, if I can show you your results in a visual form, now not only can you see your answer, you can see if it makes sense, but now you can start seeing maybe other things that you didn't ask, things that you didn't know that you want to investigate further. And you can use those visualizations to do some navigation. So I'll give you an example of what I'm talking about here. Here's an example from one of our solutions that's called Discovery Advisor for Life Sciences. And in this case, the question, if you will, was, compare Alzheimer's disease and ALS. So, and what are the genes that are common to both of those? We could have just listed those, but as you can see, and you probably can't read this from the back, but that's not the issue here. So we got Alzheimer's disease at the orange box on the right and ALS on the left, and you can see the genes that are associated with each of them, quite a few different genes, but immediately you can see in the middle the genes that are common between both of those. So now that's interesting. So now I can look at those, and I could do things like click on each gene separately, so I can start using the visualizations to navigate to other visualizations. Maybe I could draw a circle around those and say, well, what other diseases are these associated with? And if you're a pharmaceutical company looking for the next drug or the next drug target, you can see how important this is. So the idea behind our Discovery Advisor solutions is not to give you answers to your questions, but give you answers to things you didn't even know that you needed to ask. And so that's the power of visualizations. So visualizations then show semantically related concepts, and it's visualizations like that using graphs, but it could be simple tables, could be simple lists or whatever, but it's the idea of showing you things in a way that makes the most sense and allowing you then to navigate using that. So use visualizations to navigate to other visualizations. And now that leads to the ability to make hypotheses and predictions. And you can see that in like the visualization that I showed you. You can say, well, if these two diseases have these common genes, then a good disease target for me would be other things that are related to these genes. So you can start making those hypotheses. The computer can make hypotheses for you. It can make predictions for you. This is especially interesting in medical cases where we can start looking at past cases and make predictions in terms of this patient, based on the trends I see, is going to have an adverse event within the next 3 hours. And here are the steps you need to prevent that adverse event. Next, these hypotheses and predictions then lead to insights. that might require further investigation. Insights leads into discovery, and then discovery leads to actions, which is ultimately what we're all about, is getting input from the user and then providing information that allows them to take actions. And that could be new drug targets, new investment strategies, new drilling locations, what have you, depending on the industry. So this is what we're focused on, and these are the types of things that we're building as part of our Watson solutions. We're building them into our solutions, but more importantly, we're starting to take these different interaction models and making them available separately so you can add them into your own application. So one of the, and I'll show you this later as we go throughout here, but one of the things we're focusing on is how do we make these capabilities available not only to solutions that we write within IBM, so that you can include any portion of this into your own applications. All right, so now I want to cover some of the solutions that we've built, some of the technologies that we've been working on for the I guess last 4 years since the game of Jeopardy came out. The first one is I guess one of the original solutions we worked on. It's really our flagship solution, and if anybody's been watching TV lately and they say, you know, talk about Watson doing medical treatments, and if you were watching the Masters, you saw that like every half hour you saw the commercial where they talked about Watson doing giving treatment advice to physicians. This is the solution that they're talking about. It's called Watson for Oncology, something we worked on with Memorial Sloan Kettering. Currently covers breast, colon, rectal, and lung cancers. And we're now rolling it out to many more cancers that will finish up this year. Basically learn from the top oncologists at MSK in terms of understanding what are all the factors involved in giving a treatment or prescribing a treatment to a cancer patient. And so we worked with them, worked with their past cases, worked with their outcomes to come up with that, build an application that any oncologist in the country and in the world, we're selling this everywhere around the world, can use, and it'll pull the information that it needs from electronic medical records, and it will ask you it'll basically have a dialogue with you through prompts that says, you know, based on the information that you gave me, here's the treatment that I would recommend. But here's the next level of information that if you could provide this, if you could provide their creatinine clearance level, for instance, then I could do an even better diagnosis, and we'll even give you help for why would I even be asking you for that information. It'll tell you why. And then it'll give you the answers. You can see on the right here, the treatment plan options here. We can identify all the options available through the guidelines, the National Cancer Guidelines, and then we can tell you which ones are right for your particular situation. So it gets it personalized to a specific treatment for this specific patient. And it could be, you know, it could be this endocrine therapy followed by this radiation therapy followed by this chemotherapy for this long and stuff like that. Gets to that level of detail, is able to show them survival statistics and things like that. So the patient feels better about knowing what's going on, what the survival rates are, gives the physician a better feeling that they've included all the information that they can. It helps them feel better about their diagnosis. If it matches what they thought they were giving, then they feel more confident. If it doesn't match, then we can give them all the statistics, we can give them the reports, the main studies that show why this is, and but in the end, they're free to choose whatever solution that they want, because they're still the final arbiter in that. So this is a key solution that we have. This is the one we cut our teeth on, I guess you'd say, with Watson, and and is now available for the general oncology community.
I got a question.
You bet.
What's it written in? Who's writing the code? And where are they?
Okay, it's primarily Java is what we write everything in. It's written by Java developers. So I guess the job descriptions that go into this, we have Java developers, we have program managers, we have testers, we have analysts, we have subject matter experts, we have linguists.
How many of these guys are in the U.S. and how many are in Asia?
They're all in the U.S. They're split between here in Rochester and Raleigh, North Dakota, or Raleigh, North Carolina. But the leadership for this is here in Rochester. And then everything we do under the umbrella of the MSK doctors. So we've got the best breast cancer doctor.
Sorry, what's the acronym?
Memorial Sloan Kettering, MSK. So they're the ones who provide the subject matter experts and the medical. So they would not approve us releasing this without this being medically accurate. Yep.
Is that the only input screen there?
No, this goes on for pages of information. So we'll pull as much out as we can through the electronic medical record. And then we'll say what's missing, which could say, well, maybe he's got to go to another report to go find that information, or maybe they've got to run a test to find that information.
Is there a primary data center where this is going to house this, or is it distributed?
Okay, yeah, everything we do with Watson is cloud-based, so all this runs in the cloud. The actual patient data comes from whatever institution. IBM's hosting it.
Pardon?
IBM has a cloud.
Where are their data centers?
Raleigh and Boulder. So Raleigh is the main center with Boulder as the backup. And so we have a lot of our solutions. It's all highly secure, HIPAA compliant. All the data is encrypted, so no protected health information gets out and things like that. Another question?
You mentioned the types of expertise that's involved in this. Are we talking dozens of IBM people, or hundreds, or thousands?
For this, well, obviously for the Watson Health Organization is in the thousands, but this particular solution, and of course this solution draws on many people within the Watson Health Organization. This particular solution has on the order of 40 people that we put together to pull this information. And now and that was to do it the first time. That's what we just originally carved out these 4 cancers, and it took us a couple of years to do this, to get it right, to get everybody happy, and the treatments and the treatment recommendations it makes are 95+% accurate in this case because of the demands that MSK put on us. They wouldn't release it if it's not at that level of accuracy. Not everything we do is that accurate because of what I told you before. If you got messy data information in, garbage in, garbage out. But in this case, we make sure the data coming in is accurate because we're asking the physician to validate it. We'll pull it in. We'll pull it in as accurately as we can. We'll display it to the physician. We'll tell them where we got it. We'll show them how we pulled it out. Or if we derived some of this information, we'll show them exactly how we derived it. But they have to validate that we pulled this information out and it's accurate for this patient. So we know we got good data coming in. And once we've got that good data, we've got enough training and machine learning and examples and that we can with very high accuracy provide an answer like an MSK doctor would. And then one of the things we're working on is now that we know how to do that, we want to open it up so we can give it answers at other institutions. So it's going to be easier now for others to say, well, that's, we practice a little differently in this state or in this country, and we want to be able to tailor this for that particular environment.
So Bill,
Yeah.
if more learning happens in the industry for oncology, I suppose that happens, right?
Yep.
Does Watson then learn that?
Yes.
Okay.
So there's two ways to do it. We're building a version of this that is just based on the published literature. So when things come out, when the guidelines change, and they, whether they change quarterly or monthly or daily, we can bring that in, incorporate that, and build that into the solution. And that might get you to the, the top 5 treatment options for this, maybe top 10. But if you want to get to the top 1, then you got to get subject matter experts involved. So in that case, then we'll wait for the MSK doctors to say, yeah, we've read the literature, we agree with this guideline, so you can put it in. But even guidelines, even industry guidelines are just consensus. They're not, they don't necessarily represent any particular practice, and not every practice agrees with the guidelines because they're consensus, and the guidelines are incomplete because they're only the things that they could agree on. But we want to get to more detailed things, so we got to get to something so we've got to have a source of truth on this. In this case, MSK is our source of truth. All right, let's look at another one. So the previous solution was for what we call solid tumor cancers. We were also working with MD Anderson Cancer Center at the same time with the liquid cancers, the leukemia-based cancers. Very similar, different approach. The previous one is something we sell to everybody. This one was done particularly for MD Anderson, but they're looking, in the future to be able to sell this solution too. So now we have both the solid tumors and the liquid tumors covered. That one led to then another related solution with MD Anderson and the Texas Medical Center on diabetes care. So in this case, they've got 70,000 individuals in the Houston area with diabetes, and it's costing them $700 million a year, insurance and things like that, to keep these patients healthy. And a lot of that is just, it's very difficult to monitor these people. So the idea behind this solution is to help use Watson and cognitive technology to better keep track of what these individuals are doing and optimize their care based on their current health and activities. This one, the Watson for Clinical Trials Matching, is the one we're working on here with Mayo Clinic. So this one was guided by Mayo Clinic. This one deals with, given a particular patient, what is the best clinical trial for this patient, or what are the available clinical trials that match this patient's capabilities. The reason this is important, and we learned this when we worked with MSKs, with MSK, we're targeted for saying what's the standard of care, what do the guidelines say is the right solution for this. But MSK was very careful and adamant in pointing out to us that for cancer patients, the best solution is always to look at a clinical trial first. Clinical trial, you get the latest treatments, you get better care, you get more personalized care. And in cancer, you're not getting placebos or anything like that. You're getting real care on this. So they said, always look at a clinical trial first. Despite that, the statistic over here, 3% of all cancer patients are in clinical trials. Well, that's not what they're saying. They want more. More people should be on clinical trials. And part of the problem, there's thousands of clinical trials available, but they have such broad, or I should say narrow, entrance criteria that it's almost impossible to find a clinical trial that your patient matches. And to go have a physician or a physician care team go through all those trials to find one or two that this patient matches is a daunting task, and it basically doesn't get done too often. So the idea behind this solution is to collect all that information about this patient, collects all the information about all the the thousands of clinical trials out there, does a matching, does a best fit, and says, well, you know, either this patient is an exact match for this trial or it's a close match for this trial. But the things that where it doesn't match are things that you can control. So for example, your blood pressure has to be within a certain range where your patient falls out of that range, but with proper medication, they could be put into that range. That makes them eligible for this trial. That's going to be huge if we can get that, because it's going to improve the care for the patients because they get the clinical trials they need. Plus, it's going to make it easier for the pharmaceutical companies to find patients to attend their clinical trials. So there's going to be more clinical trials available. So it all builds up on each other. So we should get better care across the industry. So very, very important solution. And this is something that's being rolled out here at Mayo today. And they're the first ones to use this.
So who decides what the math is on that correlation? Is it an MD? Is it somebody sitting in a cube out at IBM?
Well, the pharmaceuticals first set the clinical trials, and they give all the criteria that you have to meet for that. And then what we did was working with Mayo is to try to interpret that criteria. So they had to train us, and then we had to train Watson to say, well, when they say, you know, I'll just use something very simple. They can't have high blood pressure. Well, what do they mean by high blood pressure? What do they really? What does that translate to medically? Then we can match that. So obviously, there's more complicated.
You're creating a score of some sort for
yes,
them,
and we create a score for that. And
so who's doing that? Who's making that algorithm?
Well, that's the training that we take Watson through, the machine learning. Oops, it wasn't me. must be close to being done. There we go. Through machine learning, they train that. We work with them.
I don't know what that means. Tell me what that means.
Machine learning?
Yeah.
Yeah. So it's basically learning by example. So we put in a set of
neural networks. Is that what it is?
Logistic regression is the machine learning algorithm we typically use, but you know, it looks at you know, false positives, false negatives, and you have training data, you have blind data, and those types of things, and you just keep iterating on that. You add more cases, you change the algorithms, change the features until it's giving you the accuracy that you're looking for.
So who's got the expertise to do that? Somebody here or somebody over there?
No, we have that expertise. So IBM has that machine learning expertise, and then the Mayo Clinic provides the subject matter.
Mayo is setting the weights.
Right.
They'll help us set the weights. They'll help us set what the factors are that we need to include. So if we're not reaching what we want, then we go back to them and say, why not? Was the training data bad? Are the results that it's showing different than what it says? So we did this like with the oncology solution when we first started out. It was, you know, here's a case and here's the answer to that case. And we learned based on that, and it was giving us the wrong answers. And we asked them why, and we took a physician through that. Well, the reason they gave this was because of these factors. Well, you didn't tell us that was a factor in your decision-making process. So now we added that factor. And in some cases, the reason they did it is because it was a patient preference involved, but that preference wasn't indicated in the case itself. So now we had to relook at that and said, well, you're going to have to go through this and tell us not just what they did, but if you know, tell us what you would give today just based on the information that we have. So that whole process, that's why it takes a while to do that, because Watson is a learning system. It'll learn the wrong things just as fast as it'll learn the good things, the right things. So you have to be very careful. You have to watch over it. And you need subject matter experts who know what they're doing to be able to do that, to get to the level of accuracy we're talking about here. If what you're just looking for is what does the preponderance of evidence out there show me and tell me that I can make use of, then you're not so particular. It's kind of like the Jeopardy answer, right? There's, what actor star, what actors starred in Star Wars? Well, there's a preponderance of evidence that lists exactly what those are. So that's something we can find. But if you're looking for, one very specific answer like that we're doing here, it becomes much more difficult. Question?
So in this learning process, are you getting to the behavior of a single physician, or is it a group of physicians that you try to match?
Yeah, good question. When we first started, when we started this, I think this is probably 3.5 years ago. We set our sights on we're gonna do whatever the evidence says, right? Well, the evidence out in the world, and that never came upon a particular answer, never converged to an answer. So because everybody did something differently, and that's the problem. That's why we need solutions like this. So then we got to, okay, so what does an institution do? So then we worked with MSK and said institution. So we started interviewing all the breast cancer doctors. Well, it turns out they didn't agree either. So even within their practice, and they've got a very disciplined practice, when you give them a case and you tell them, you ask them, what would you give? And we asked, 5 breast cancer doctors, you get 3 different answers. And when we couldn't have that, we needed to narrow it down. So we typically picked one. And it got to the point where we got, when we were testing this thing, then we'd run this through and Watson would come up with an answer. And the doctor would look at this and say, oh, that's not what I do. That's not the right thing. And so when we'd study it and we'd say, well, we can go back and see, why did Watson pick this? And we said, well, we picked it because of this. And the physician would go, oh, yeah, that's right. I didn't realize that, or I didn't see that, or I didn't read it. They read cases and they miss things. And it got to the point where Watson was picking things better than they could, again, because of the time they could spend on it and things like that. So originally, MSK, we were just building this for like community hospitals and things like that. And MSK didn't think they were going to use it themselves, but now it's good enough where MSK says we've got to have this in our practice too, because we don't want to miss these types of things. I only have two more charts. One, I talked about the Discovery Advisor for Life Sciences, which is started for pharmaceutical companies who are doing, looking for drug targets, new drug targets and things like that. And then we've got the Genomics Advisor, which deals with given the genome of your body or of your tumor, then what are the right treatments for that. And then the last thing I want to leave you with is something I mentioned earlier was, we focus on these solutions and understanding these solutions, but now we're turning this into a set of services, these cognitive services, so that we want to build up an ecosystem of people building applications like we built. So we don't have to build the next treatment advisor for, cognitive treatment advisor. Someone else can build the next cognitive diagnosis advisor and things like that, using the techniques that we've built over the years, using the services that we're mapping this out into a bunch of services that people can start building their own applications on. All right, so that was what I had planned to cover. Let me make sure there's light here so people can see. So I'll take questions, but again, thank you for allowing me to talk with you today. Question back there.
So how is the guidelines for the NCCN and the MSK decision-making process?
That is the first thing we go. So we do not give a recommendation if it does not conform to the guidelines. So that's our filter. So every answer that we give is within the guidelines, but the guidelines will give 20 different chemotherapies that are right for this patient. We then ask more questions than the guideline gives, like, does this patient have neuropathy? Well, if he does, that eliminates a bunch of treatment options. the NCCN guidelines didn't ask because they couldn't come to a consensus on that. MSK says if you have neuropathy, you don't give bevacizumab or something.
So for first line, second line, third line treatment, right?
Yep.
Does it go through that? I know that the NCCN Guidelines does that. That's the first line, the second line, third line.
Yes.
And that's important.
Yep, we do first line, second line, and we're working on third and subsequent lines. Now, those are the more difficult ones that oncologists have trouble dealing with too. So we're teaching it how, again, MSK deals with second and third line treatments. Yeah, right there.
So, who are some of the major competitors in this area, and do they use cognitive computing or some type of AI?
It's kind of a mixture. Competitors in this space would be like Flatiron and things like that that are knowledge-based systems and things like that. In the cognitive space, everybody's trying to get into this, Google, Microsoft, and things like that. But they're still, we've got quite a lead on the capability, especially in the healthcare industry, because we've been working on this so long. But those are some of the people working in this space. Yeah.
Did you pick the oncology because it's such a broad knowledge domain? Because, I mean, I worked with the protocols they use for treatment here at clinic, and for adults, there's at least 12 to 15,000 adult protocols and another 8,000 pediatric protocols. And then based on the type of cancer, the grade, and all other contributing conditions, they pick the most appropriate protocol. And it changes at the time the diagnosis is made. So it's a very dynamic system with a lot of wide domains, and you have a lot of variables to fit in. So something that can do a real-time assessment would make more sense.
Yeah. We picked cancer just because of how many incidences there are. I wish we had picked something else because it turned out to be one of the most difficult ones. So we're looking forward to our next diseases. Although what are they going to give us? Diabetes and cardiology, right? Those aren't easy either. But at least we know how to do this. And one of the things we're doing now is how do we're called industrialize this. So now that we've done this kind of for one space, first of all, we'll finish this with the rest of the cancers, and then we'll move into these other diseases, try to use the same techniques.
But did you determine some sort of conceptual patterns or frameworks to work off of for your solution sets? Or is it all vary every time you do an implementation?
No, we have a very precise way of doing this in terms of finding out, what are the, first we define what attributes are important, and then we decide what the inclusion, exclusion criteria. So can we exclude certain things, like neuropathy, we can exclude some things. And then we've got treatment preferences that we can learn from past cases, and we can learn from physicians. Like we always prefer this over this when the patient has that. And we build those kinds of things into our entire algorithm. So it's a well-defined formula, and we're building the tools so that we can just plug that information in for these new cancers and new diseases. Right here.
To what extent do you use the massively parallel processing capability?
Well, right now for this solution, we don't require a lot of massively parallel processing because we're dealing with a small number of oncologists, right? And people who use this for a particular institution is going to be on the order of 20, 30. But I think the broader question is, what do we use in general for some of our other Watson solutions that do require big data and scalable? So, we're looking for, Hadoop and Spark and those types of technologies to help us scale this out, especially when we run real-time analytics or when we're dealing with patient data. By the way, I should mention that, IBM has purchased the rights. Well, we purchased 3 different companies, Exploris, Phytel, and now Truven. which now gives us access to over 350 million patient files, basically, that we can use now in the future for training data and things like that. Massive amount of information. Even like the Explorers data, I think they get 1 million updates, 1 million new patient records every day, just updates of that patient. So all that's got to be processed within 24 hours. So we're looking at Hadoop and Spark infrastructure to be able to do that.
Is that just claims data?
No, this is real patient EMR type of data. Truven gives us the claims data. Explorers has the clinical data. Truven has the claims data. So now we've got both aspects of that.
Do patients have the right to opt out of that?
Patients, yes, all of it is de-identified. Before we can use it, it's de-identified, and we've got agreements with the providers that we have secondary use rights to that for analytics.
So if it's de-identified, how do you track a patient over time to understand outcomes?
Well, that's so that the massively scalable stuff where we're doing analytics, that's de-identified. But if we're doing individual patient stuff, then we have rights to that in a different manner. So so that's kind of on an individual patient, and for that the patients can opt out. Question up there?
So I like the clinical trial matching, but probably one aspect, I don't know if it's included, is why the numbers are so low, is the insurance companies. So when the clinical trials are happening, somebody has to pay for the imaging, the testing, and every one of those things. And so the companies and whoever is conducting clinical trials has to basically negotiate with the insurance companies. So if you could have maybe a list of the insurance companies that whoever's doing the clinical trial, who's involved in it, right? Maybe it'll be better for the patient. Then they can see that, okay, my insurance company is actually involved in this, has been participating in this clinical trial.
Very good point. Yep, and that is something our roadmap is to get more involved in the payer aspects of this, and if we can automate that, even better, right? So if you sign up for this clinical trial and we can pass that information and get that automatically approved through the insurance company, it's going to make that whole end-to-end process better. All right, I think I'm over my time. So
Thank you.
yeah, thank you.